today's class, we will learn some laws and rules or relations of set theory which are very important and which are frequently used when we work with set theory. So it's always recommended that we learn about those laws and rules. If we learn about those laws and rules, then it will always help us to simplify the exercises using the concept of set theory, and it will also save time during exam. Let's learn one by one. Now suppose if A is a set, like it has elements like 1, 3, 5, 7 and 9 say, and phi is an empty set, so phi has no element. So if these are the two sets, then the union of A and phi will be what? It will be A only. Why? Because A has 5 elements and phi has no element, and union is what? Union is basically addition of two sets. So in that new set, the elements will belong to either A or B, means phi here. And since phi has no element, so in the new set, which is the union of A and phi, definitely all the elements will come from A only, or all the elements will belong to A only. So this is the result. Now the second relation is union between the set A and a universal set, say E. Mostly the universal set is represented by U, but since here we are performing the union operation between two sets, one of them is universal set. So here I am representing universal set by E. So union operation between any set A and universal E will be what? We know the universal set is a bigger set or superset, we can say, which has all the elements of related sets. That means when we will perform union between a universal set and any other set, definitely that universal set will have all the elements of A. So when we will perform the union between universal set and another set, and we know that it is the addition operation between these two sets, and when we add the elements, we don't repeat any common elements. So here all the elements of A are common between A and E, so we will not repeat them. Now let's assume that universal set is a set which has the elements 1, 3, 5, 7, 9, and these are the elements of A, and apart from that it has other elements like 2, 4, 6, 8 and 10, and A has these 5 elements. So universal set already has all the elements of A. Now when we will perform union operation between A and E, in the result we will have only all these elements which belong to the universal set. That means when we perform union operation between a universal set and another set, the result of union will be always that universal set only. Now the third relation that we will learn today, that is also related to union. So here, that if we perform union between two same sets, so here A is already defined, we know what it is, and when we will perform union between same sets A only, the result of union will be A only, because here it has 5 elements 1, 3, 5, 7, 9, and here this second set also has 5 elements 1, 3, 5, 7, 9, and we will be adding all the elements of both the sets, but we will not repeat any common element. So here all the elements are common, so we will, or the new set will have only 5 elements only. So always when we perform union operation between two same sets, then the resultant set will be same as the set on which we are performing union operation. Now these three results were based on union. Next we will learn some relations based on intersection. Now here again, if A is any set and phi is an empty set, and if we perform intersection operation between A and phi, now you by yourself can understand what will be the result. A is this set which has 5 elements, and phi is an empty set which has no element. And intersection is what? Intersection is the operation where we will have only the common elements between two sets. Since phi has no element, that means between these two sets there will be no common element. No common element means in the resultant set we will have no element, and no element means that the resultant set will be again will be an empty set. That means if we perform intersection operation between any set and an empty set, then the result will be, or resultant set will be also an empty set. Then the next relation that we will learn today is, again, if we perform intersection between a set, any given set, and universal set, then we will see what would be the result. So A has 5 elements, and since E is universal set, so it has all the elements of related sets. That means the bigger set or superset. But between these two sets, only these 5 elements will be common, right? Because E has many other elements also, but these 5 elements will be only common. So when we will perform intersection, then the result of intersection will be A only. But when we perform union operation, the result was the universal set. But when we will perform intersection, since this is about the common element, so it will be, the result will be A. Now the third operation or third relation that we will learn today is, now we will perform the intersection between two same set or two equal set. So intersection will be what? This has 5 elements and the second set also has 5 elements, and all the elements are same, right? So that means intersection operation will, or in the new set or the resultant set, that set also will have 5 elements, so it will be equal to A. So here the interesting point is, when we perform union operation between two equal sets or two same sets, then the result is the same set only. And when we perform intersection operation, the result of intersection is also the same set only. So here the result of intersection and union are same. Otherwise, if one of the set is empty set or universal set, the result varies. So these three relations were based on union operation, and these three relations were based on intersection operation. Next we will see few more relations based on set theory. Suppose A is any set, then we will see that what will be the result of union operation if we perform that union operation between A and A complement. A complement we have already learned in our previous one of our previous classes, that complement is what? Suppose if we have a bigger set or universal set, and if we have a subset like A, so the complement will be the elements which don't belong to A, but they belong to the bigger set or universal set. Now suppose the universal set that we took in the previous example, say, so 1 3 5 7 9 2 4 6 8 10, this was our universal set, or if this is our universal set, suppose, and the set A is, or A has these 5 elements 1 3 5 7 9, then A complement will be, or in that set we will have these 5 elements which don't belong to A, right? So it will be 2 4 6 8 and 10. So this is our A and this is our A complement. Now when we will perform union operation between A and A complement, it is what? It is the addition of two sets, and we will not repeat the common elements, but between A and A complement there will be always there will be no common element. So when we will add these two sets, or when we will perform union operation between these two sets, it will basically, it will combine all the elements of A and all the elements of A complement. That means we will get back this universal set only, or the bigger set only. That means the result of this union operation will be E here, which means universal set here. Now the second relation that we can derive here, that if we perform intersection operation between A and A complement, then it will be what? A means this has these 5 elements, and A complement this has just different 5 elements. So when we will perform intersection, means we will, the new set we will have the common elements, but here when we have a set and its complement set, there will be always no common element, and there if we perform intersection operation, that means in the resultant set there will be no element, because there is no common element, so there will be no element. That means the resultant set will be an empty set. Now there are few more relations that we can derive here, some conclusions you can say. Suppose if we have an universal set like this. Now if we go by the actual definition or concept of empty set and universal set, then empty set has no element and universal set has all the possible elements of all the possible sets. That means if we take an universal set, that means we can assume that it has all the elements, all the possible elements. So if we now take the complement of the universal set, since universal set includes all the possible elements, there is no more element that could be included in that set. So when we will take the complement of the universal set, that means nothing was left to be included in that universal set. So if we take complement of it, then there will be no element in that new set or in the set which is complement of the universal set. That means since there is no element, so we can say that element will be an empty set. Now on the other side, if we think this way, that we want to take the complement of an empty set. Empty set means what? No element. And complement of empty set means what? It has all the possible elements. That means we can say that complement of empty set is universal set. So these two are also very important relations in case of set theory. Next, we will learn some laws and rules of set theory. The first law, it is commutative law. Now, suppose if we have two sets, A and B are any two sets, then what we can conclude here is, suppose A is an set of alphabets and it has these elements A, C, say D, then E, and say F. And B also is a set of alphabets and it has elements like A, then E, then F, then M, and then N. This as per cardinality, it has the cardinality is same of A and B. It has 5 elements. It also has 5 elements, but they are not equal sets because the elements are not same. Now if we monitor closely, then we can find here that A is a element which is common between A and B two sets. Also E is such element which is common between A and B, and also F is such element which is common between A and B. And C, D in case of A and M, N in case of B, these are distinct elements, these are not common. So now if we perform union operation between A and B, the resultant set will have these elements. First we will include all the elements of A, and then we will include all the elements of B, but we will not repeat any common elements. So A, C, D, E, F, all the elements of A. And now since A, E, F, these are common elements between A and B, so we will not repeat because they have already been included here. So we will include all the different or distinct elements which belong to B. So they are M and N only. So these are the elements of the resultant set, which is the result of the union operation between A and B. Now suppose if we perform union operation between B and A. So B and A means what? First we will include all the elements of B. So it will be A, E, then F, and then M and N. And then we will include all the elements of A, but we will not repeat the common elements. So here A, E, F are common elements, so we will not include them, but we will include C and D. Now if we rearrange all these elements of this resultant set, then it will be A, C, D, E, F, and then M and N. So what we can see here, that this set has 7 elements, and this set also, this resultant set also has 7 elements, and all the elements are equal. So this new set, the resultant sets are equal sets. So we can conclude from here that if we perform union operation between A and B, where A and B are any two sets, and if we perform union operation between B and A, basically these two operations will give us the same result. So this is our commutative law based on union. Next we will perform intersection operation between A and B. So if we perform this way, intersection operation between A and B, now here intersection means only we will include the common elements in the resultant set, and the common elements are A, E and F. So in the resultant set we will have only these three elements A, E and F. Now if we perform intersection operation between B and A, then again we will include the elements which are common between B and A, and we will take from B. So it will be again A, E and F only. So whether we are taking from the first set or whether we are taking from the second set, since we are considering only the common elements, so the result of intersection between A and B or B and A, means first and second or second and first, they will be same only. So we can conclude this intersection result between A and B will be equal to the intersection result of B and A. So this is our commutative law in case of union, and this is our commutative law in case of intersection. Next we will learn important relation based on subset. Again we will take the same sets A and B. Now here first what we will do, we will take the union operation, we will perform union operation between A and B, and that resultant set will have what elements here? A, E and F. These three elements are common. So as we have seen that this will be the elements of the resultant set. Now if we go by the concept or definition of subset, we know that subset is basically a smaller set and superset is a bigger set, and all the elements of subset are the elements of bigger set also, superset also. But the vice versa is not true, because all the elements of the superset are not the elements of subset. So here when we have performed the union operation between A and B, we have obtained this set where we have 7 elements. Now if we evaluate the elements of this resultant set, which is the result of union operation, here we can see it has these elements A, C, D, E and F. And also set A has these 5 elements A, C, D, E, F. So that means here we can say that A has these 5 elements, B, A union B, that resultant set also has these 5 elements, and along with them it has few more elements also. So we can say that A is a subset of this resultant set, which is the operation, which is the result of union operation between A and B. Similarly, if we again evaluate the elements of this union operation, then we can find here that we have elements like A, E, F and M and N. So we have these elements also, which are the elements of B also. So that means we can say that B has 5 elements, and all the 5 elements are also part of this resultant set. So we can say at the same time that B is also a subset of this union operation between A and B, and that is always true. Now the third relation that we can conclude here or draw here is that this resultant set has 7 elements, and if we think this set with respect to a universal set may have all the elements, all the possible elements of the universe. So with respect to that bigger or superset, we can say that these 7 elements will be also part of that universal set. So A union B, that resultant set will be a subset of the universal set. So whether we are performing in union operation between two given sets or intersection operation, that resultant set will be always a subset of the universal set. So any set will be subset of a universal set. So here A union B will be subset of the universal set. Now next we will see, if we perform intersection between two any given sets, then what conclusion we can draw. So we will again take the same set A and B, and now first we will perform intersection operation between A and B. So intersection means common elements. So common elements, we have already seen that A, E, F are common elements. So the new set, resultant set, will have three elements only, and they are A, E and F. Now let's see what conclusion we can draw. So when we will perform intersection operation, it will have three elements. And again, if with respect to A and B separately, if we see, then we can find here that A has these three elements, and along with those three elements it has two more elements, C and D. So with respect to this resultant set and A, this is a smaller set, this is a bigger set, and these three elements are also part of A. So we can conclude here that this new set, new resultant set, which is the intersection operation between these two given sets A and B, it will be a subset of A, right? It has three elements, and these three elements also are the elements of A, but along with that it has two more elements. Similarly, again, if we assess this resultant set, and if we assess this set B, here also we can find that these three elements are common. Definitely we performed intersection operation again, and along with that it has two more elements, M and N. So again we can say this set will be a subset with respect to set B. So when we are performing intersection operation, the resultant set will be the subset of those two given sets. Now here again we can say that if we perform intersection operation between A and B, that will be again subset of the universal set, because universal set again has all the possible elements, and it has only three elements, and these three elements will be also part of universal elements. So when we will be performing intersection operation between two given sets, the result will be, the resultant set will be a subset of the universal set. Now the next operation will be based on difference of two sets, and for that again we will consider the same sets A and B. Now if we perform the difference of A and B, then it will be what? The difference means we know that it will include all the elements of A, which are elements of A or which belong to A but don't belong to B. So that means first we will see what are the elements which belong to A but don't belong to B. So here the common elements are A, E and F. So they belong to A as well as B. So we will not consider those elements, because we will consider only those elements which will belong to A only but will not belong to B. And if we go by that concept, that there are in A set, there are only two elements which satisfy that condition. So the resultant set, which is the difference between A and B, will have only these two elements, C and D. Now separately, if we assess this relation A and then intersection between B prime, then let's see what elements we will have in the resultant set. So first we will find the complement of B, and to simplify our work and to simplify our understanding, if we suppose assume that our universal set is the set of alphabets only, it's not the set that can accommodate all the elements of the universe. Suppose it is a set which can accommodate only the alphabet that we know. Now so it will have what? It will have 26 elements. So it will start from A, B, C, and then finally it will be X, Y, Z. So this universal set will have 26 elements. Now with respect to this universal set, if we now find the complement of B, complement of B means what? In the set B we have 5 elements, and in the universal set we have 26 elements. That means in the set which is complement of B, that will have 26 minus 5 means 21 elements, right? So it has 26 and it has only 5 elements. So in this set, which is the complement of B with respect to this universal set, it will have 21 elements. And what are those 21 elements? Since it has A, so we will not include that. It doesn't have B or C, so it will start from B, C. Then it doesn't have D, so it will be D. Then it has E, F, so we will not include them. Then F, then G, H, and so on. Then it will not include M and N, and then other than that, rest of the alphabets it will include. And in total, this B complement will have 21 elements. So what we have to remember here, that this B complement set will not have A, E, F, M, N, these 5 elements. So now if we perform intersection between A and B complement, so intersection means we will find only, or we will consider only the common elements between A and B complement. So between A and B complement, it has 5 elements, it has 21 elements. So we have to find what are the common elements. Here A is not common, C definitely it is common. So here C is common between A and B complement. Also D is common between these two sets. And then B complement doesn't have E and F, rather it has G, H, and all other elements excluding M and N. So that means between A and B complement we have only 2 elements common, which are C and D. So the resultant set will have these 2 elements, C and D. So what we can see here, these two results are same. So what we can conclude here, that if we take the difference between two sets, then that result will be equal to, if we perform the intersection operation between one set and the complement of the other set, and that is true for any two given sets. Now if we perform B minus A, so B minus A will be what here? So we will include the elements which belong to B only, but they are not part of A. So here we have only 2 such elements, M and N. So B minus A will be, or will have, the new set will have only these 2 elements, M and N. Now if we perform B and then intersection with A complement. So A complement means here what we will have, this new set with respect to this universal set, it will have all other elements other than these 5 elements from E. All the elements from E other than these 5 elements. So we will exclude A, then we will include B, we will not include C, D, then also E, F, then it will have G, then H, and all other elements, then M it will have, then N it will have, then finally X, Y, and Z. So these will be the elements of A complement, and here also we'll have 21 elements. As A has 5 and the universal set has 26, so 26 minus 5, it will have 21 elements. Now if when we are performing intersection between B and A complement, so means this time this set and this set, so we have to find if there is any common element or not. There are. A, E, F are not part of A complement, but here we can see that M and N, these 2 elements are common between B and A complement. So here also this result will have, or this resultant set will have M and N. So here also we can conclude that if we take B minus A, means we are taking the difference between second set and first set, so it will be same as when we will perform intersection between the second set and complement of the first set. So these 2 important relations we have derived in case of difference operation between 2 given sets. Now next we will see the De Morgan law in case of set theory, which is very important. And for that we have chosen again the same sets A and B having same elements, same number of elements and same element. Now the De Morgan law says, the first law says that if we perform union operation between 2 given sets, and then of that resultant set if we take the complement, then it will be equal to the intersection between the sets which are itself the complement of those individual sets. So we can verify this law or this result with these sets. Now for that Again, we will take this universal set which will have all the 26 alphabets. So here we are taking this 26 elements only to simplify our work. So here A complement will be what? A complement will be what we have seen in our previous law. So A complement will not have these 5 elements. Apart from them, it will have all other 21 elements from this universal set. So it will have B, then C, D, E, F we will exclude from here. So it will be G, then H, and so on, and XYZ. It will end at XYZ. So in total it will have 21 elements. And again, if we find the B complement, then B complement will have, again we will not include these 5 elements. So it will have B, then C, then D, and then we will not include EF. So it will be G, then H, and definitely it will not have MN. But A complement, it has MN, X, Y, then Z. So between A and B, if we perform union operation first, then it will have, what are the elements? It will have, union means it will have A, C, D, E, F, all the 5 elements of A, and then since these 3 elements are common, so we will not repeat them, but we will include M and N. And if we take the complement of A union B, then with respect to universal set, it will have, universal set has 26 alphabets, and this set has 7 elements. So in this set, which is the complement of this union operation, it will have 19. 26 minus 7, it will have 19 elements, because we are taking complement here. So what will be those 19 elements? A we have here, so it will be B. C has, then we have C here, D, E, F, then we will have G, then H, then all other elements apart from other than M, N, and then finally X, Y, Z. And if we take the intersection operation between A complement and B complement, then it will have, what are the elements? A complement means we have these elements, B complement has these elements. So what are the common elements? We have common element here B, here we have B, then C, D we will not include them, then G, H, and all other elements after that, all other alphabets. But here we have MN, but B complement will not include MN because B has MN. So B complement will not have MN, but A complement will have MN. But since we are performing intersection operation here, so MN are not common between A complement and B complement, so we will not include them. So what are the common elements? B, then G, H, and C, D only B complement has, and MN only A complement has. So after H we will have all other alphabets other than MN, and then after N we will have all other alphabets till Z. So in this set we will have B, then G, then H, and then all other alphabets, finally X, Y, Z. And what are the elements it will not have? It will not have MN, it will not have CD. These 4 elements are the elements which are not common between A complement and B complement. So A complement has 21 elements, but it will not consider MN. Rest 19 elements it will consider, and that will be part of this resultant set. Similarly, from B complement also, it will not include C and D, but rest 19 elements it will consider here, or it will include in this resultant set, because the rest 19 elements are common with A complement. That means in this resultant set also we will have 19 elements which will be equal to this resultant set. So we can conclude that if we perform union operation between any two given sets A and B, and then if we take the complement of that union operation, then it will be equal to the intersection operation of their individual complement set. Now we have another law based, which is part of De Morgan's law, and that is based on intersection. So if we perform intersection between A and B first, and then of that result if we take the complement, then it will be the union operation between their individual complementary sets. So it is similar to the first law that we have learned first. So in the first law, what we have done, we have performed union operation first, and then that is equal to the intersection of the complementary sets. And here we have performed intersection operation, and we have taken the complement of that, and that is equal to the union operation between the individual complementary sets. And the way I have verified this result or this law with these examples, with these sets A, B and E, similarly this law also can be proved or verified with these similar sets. So I am not going into that detail. If you want, you yourself can try it. Next we will see the last set of relationship, though we already know this. Suppose if A and B are two sets, now A and B will be disjoint sets if A intersection B is equal to null. What this means? Null means it is an empty set or null set. So when we will perform intersection, means when we will go for searching the common elements between A and B, we will not get any common element between them. That means this will give empty set, and if there is no common element, that means these two sets are not overlapping sets. So these two sets are disjoint sets. Now again, this A and B will be joint sets, that means overlapped sets, if A intersection B is not equal to null, because A and B are joint sets, overlap sets, and since A and B are overlapping, that means there has to be at least one common element between A and B, and that's why if we perform intersection operation between A and B, it will never be an empty set or null set. So this is an important relationship that we should remember in case of joint and disjoint sets. With this, I end today's class. Thank you.